Welcome everyone. In this video, I'm going to show you how you can use Google Refine to transform a tabular data into RDF data. So what we'll have is a data in a tabular format, so a CSV file, a comma separated value file, and we'll transform it into RDF as we mentioned. Now, assuming that you have followed the instructions in the lab sheet, lab number 3, the instructions there tell you where to download Google or Open Refine. Now it's called Open Refine. So it tells you where to download it, and it tells you where to download the RDF extension that we need, and it tells you also where to extract things and where to place that RDF extension after you extract it so you can get it working. And it also tells you how to use the command line to actually run Google Refine. So in this short video, I'm assuming that you've done all that and you have managed to run Google Refine or Open Refine, as you can see in front of you now. Now, to create a project, we click on Create a Project, and basically we need to now import our data. Our data, as we mentioned, can be TSV, maybe tab separated value file, CSV, or maybe Excel sheet, JSON file, XML file, and so on and so forth. And you can browse your computer. If you have the file somewhere on your computer, you can get it from there, or you can provide a link to that file if it's available maybe somewhere on your web space or somewhere else on the web. Or you can actually open the file and copy the contents there and then paste them here. I believe on the Windows machines currently, browsing and bringing the file doesn't actually work. So here we're going to actually copy and paste the content of the file. So let me do that. I use my command line to find, by the way, I'm using Ubuntu Linux here. I recommend everyone to install Ubuntu Linux maybe on your machine at home, on your laptop, so you can use things much more easily. Now let me open that file, the bicycle file. We'll open it, as you can see here. I'll just Control A, Control C to copy everything, and then go back, click clipboard, and then paste, click on next, and as you can see, this is the data I imported from the file. By the way, you can open that file in Microsoft Excel if you want, and there you can see the contents in a proper tabular format, something similar to this. So now I'll give it a name, maybe my project, and click on create project. As you can see, it'll take a little while, and then the project is now created. And because we want to transform it into RDF, we use the RDF extension now. Click on RDF, edit RDF skeleton, and now we see now the column names that we have in our tabular format in our file that we imported. And what we need to do now is add prefix, so we can tell it where the ontology is. The ontology basically is the source now of properties and relations, and we want to use those relations in order to transform, as we mentioned, this file into RDF. So we'll add prefix, we'll give it a name, maybe BW for bikewise, and just get the address of where the ontology is. So people, you can copy and paste this of course from the lab. Cornell.aco.uk/tilde. This is my personal web space, and then it's bikewise Bob owl, and we don't forget the hash symbol. Put the hash symbol there, click OK, and this will try to import or download the ontology and the relations. We can of course click manage prefixes, and these are the ones that are there by default, and this is the one that we added now. So we can just maybe refresh, say OK, and refresh. So we'll tell it it's a bike, so we'll just say type bicycle, bicycle. Now notice, if Open Refine has managed to correctly import that ontology, we should see the word bicycle here. It should pick it up automatically. We know it's a bicycle because it's defined in the ontology. But if that doesn't work, sometimes for internet connection problems, then what we can do is we can add prefix. We can download that ontology file, now that owl file, download it, and let's give it maybe a different name, www, and then click on advanced. Of course, we can download it to our own local PC or device, and then do browse, and then try to find it, because I'm using Ubuntu. I can see my desktop, and then choose byquires.owl. This is the ontology. Click open and say OK. So notice now it has added that prefix, and this one is www for the local one. Now if I add RDF type and say bicycle, then as you can see now it automatically recognizes it, right? And then I say this is a bicycle, and now I start doing the properties. Now the properties, as we mentioned, they come from ontologies, and now we have access to all these 1, 2, 3, 4, 5, 6, 7. These two are the same. This is the one available online, and this is the local one. Unfortunately, OpenRefine currently can't access the one online, so we're just using the local one. And then I can say, for example, property, and now we want to give this a name, a bicycle name, and we know in FOF we have a property called name, so we'll just say name. Now again, it should automatically pick up name from FOF, but it doesn't do that. But just for the sake of explanation, I'll just use RDFS label, and you can ask Larissa about this. I don't know whether this is appropriate or not, but as we said, just for the sake of explanation, we'll just click on that, and then shop, click on property, and in the ontology, in the bicycle ontology, we have is sold by. As you can see, it automatically finds it. We'll click on that, award, and we say has recommendation. So these are listed in the lab sheet. The lab sheet tells you to choose these, right? And then delivery has delivery duration, is it? Yeah, delivery duration has, for the weight, has bicycle weight. So OpenRefine or Google Refine, as you must have noticed now, it actually brings you the closest name to the property name that you have, so the column name that you have, and it tries to do some string matching. So if you notice now, wheel size, if I say has bicycle, you notice things with the word W come to the top automatically. Has bicycle wheel size, and this one, as you notice now, has bicycle gear comes to the top, and then has bicycle price, which is there. I do that, do all those properties. So notice now again, just to repeat, these are the column names, and these are the properties from the ontology. We choose for each column name the appropriate property or appropriate relation from the ontology. And by the way, we can actually choose the type even, so we can click on that, for example, and say it's text, or maybe as an integer number if we want, if we know it's an integer, or as a date. We can choose the type, as you can see. We'll leave them as they are now to the default values. Click on save. Notice now it's telling me it's saving the RDF schema skeleton, and then say OK. Notice now on the left here, if you see this undo redo, it actually gives you the steps, right? It gives you the steps that you have done, so you can actually undo them. So if you want to cancel any step, you can actually undo it, right? Then what we do is we go to export RDF as turtle. So after we've done the RDF stuff, we just export it as turtle file, turtle format. You must be familiar with this now. You had one or two examples before. So just export as turtle, and as you can see now it's telling me you have chosen to open my project.ttl. I'll just say, for example, save. I'll save the file. It will go to my downloads, and if I check my downloads folder, my project, then it's there, the turtle file. I can open it to show you that it has actually been transformed to RDF. So this is the CSV, the normal data, right, the tabular data, and this is the turtle data, the RDF data. Now some of you might say, wow, but why is this so much data here? I mean, we could have just had it simple like this. Well, always remember, this RDF format is for the machines to read, right? This is for the semantic web, so it's for the computers to process. Do not worry if it appears as if there's too much data and it's hard to understand. Although the turtle format is very hard to, is very easy to understand because it's just plain triples. 1, 2, 3. Subject, predicate, and object, right? As we explained before, as you will learn throughout the term. Now I'm going to stop here. Thanks for watching, and I'll probably see you in one of my next videos.